Hey there, Algebra 2 students. Welcome back to Ms. McGuire's classroom. Don't forget to put your first and last name, period, and the date in the upper right-hand corner of your paper. Today we'll be doing Unit 7, Lesson 2, and our main topic is geometric sequences. So we talked about arithmetic sequences in our last lesson, I believe, Lesson 1. And so now we're going to be talking about geometric sequences, which are a little different. So today's objective is I will define, identify, and apply geometric sequences. Mastery will be demonstrated by scoring at least 80% on the extra practice. So a geometric sequence is the ratio of any term to its preceding term is a constant value. That probably makes zero sense. Let me show you an example though, and that definition will make a lot more sense. So here's an example of a geometric sequence. So you could have like the numbers 2, 6, 18, 54, and so on. And so notice that this is different than an arithmetic sequence. So remember, with an arithmetic sequence, you had a common difference. So like if you took 6 minus 2, you would get 4. If you took 18 minus 6, you would get 12. If you took 54 minus 18, you would get some number. I don't want to do it in my head right now. So we notice that there isn't a common difference, right? But these numbers seem to be related somehow. Like if I took 2 and multiplied it by 3, so 2 times 3, I would get 6. If I took 6 and multiplied it by 3, I would get 18. What happens when I take 18 times 3? I get 54. So that means that we have a common ratio of 3. And instead of adding 3 each time, we're multiplying by 3 each time. So to find the next term, the 5th term, I would take 54 and multiply it by 3, and then so on and so forth. So another example of a geometric sequence could be 3, negative 15, 75, negative 375, so and so on. So this might seem a little strange because every other number is negative, and every other number is positive, but this is still a geometric sequence because you actually multiply the previous number by the same common ratio to get the next term. So I know that to get 3 to become 15, I would multiply it by 5, right? But if I multiply 3 times 15, I would get 3 times 5, I would get a positive 15. Well, what if I multiply 3 by a negative 5? 3 times negative 5 is negative 15. Negative 15 times negative 5 is positive 75. Positive 75 times negative 5 is negative 375. So do you see why every other number is a negative? It's because my common ratio is negative 5. And when I multiply a negative by a negative, I get a positive. When I multiply a positive by a negative, I get a negative. And so that creates this sequence where every other term is positive and every other term is negative. All right. So a recursive formula. Remember, we use our recursive formula when we know the previous term. So that's the same as our arithmetic sequences. If you know the previous term, use the recursive formula. If you don't know your previous term, then use the explicit formula. So just like with arithmetic sequences, we can create these explicit and these recursive formulas, and you use one or the other depending on if you know the previous term or not. So the geometric recursive formula looks like this. A sub n, so your new term, is equal to the previous term times your common ratio. So remember that, just a couple notes here. A sub 1 is your first term in your sequence, and R is your common ratio. And I'll show you how to find your common ratio in just a minute. And I think that's all we need to know. And then A sub n is the term that you're looking for. That nth term that you're looking for. Okay. So if you know the previous term, so if you know A sub n minus 1, which is the term before the nth term, you use your recursive formula. If you don't, then you're going to use the explicit formula. And the explicit formula is your new term, A sub n, is equal to the first term times R to the n minus 1 power. Again, R is your common ratio, A sub 1 is your first term, n is the number of the term that you're looking for. All right, so example 1, is the following sequence geometric? So the way we tell if it's geometric is you take the next term and divide it by the previous term. So we're going to take 6 and divide it by 3. And we're going to see if that's equal to 12 divided by 6, 12 divided by its previous term. And then you're going to see if that's equal to 24 divided by its previous term. Well, 6 divided by 3 is 2. 12 divided by 6 is 2. And 24 divided by 12 is 2 as well. So because each term divided by its previous term is the same, that means we do have a geometric sequence, which means our common ratio is 2. So yes, it's geometric. And your common ratio, I don't know why I just added an R at the end of that. Your common ratio, R, is equal to 2. So let's just double check that works correctly. 3 times 2 would be 6. 6 times 2 would be 12. 12 times 2 would be 24. So that is our common ratio. So now I want you to do the same thing and then tell me, is the following sequence geometric? If so, tell me the common ratio. If not, you don't have a common ratio, so you don't gotta worry about it. So remember, do what we did this other time. Take the next term and divide it by its previous term. Take 12, we divided it by 6. We took 24, we divided it by 12. And see if you get the same number. Is there a common ratio? Is this a geometric sequence? So what we're asking ourselves is 6 divided by 3 equal to 9 divided by 6 equal to 12 divided by 9. Well, 6 divided by 3 is 2. 9 divided by 6 is 3/2. 12 divided by 9 is 4/3, right? 2 is not equal to 3/2 is not equal to 2 4/3. So these things are not equal. So there is no common ratio. And if there is no common ratio, then we do not have a geometric series. All right. So now we're going to actually build our explicit or recursive formulas, and we're going to create an equation, a formula, and we're going to find the 10th term in each of these sequences. So we're going to find the 10th term in each of these sequences. So for example 2, we have 4, 12, and 36. We know our first term, our second term, and our third term. If we want to find the 10th term, A sub 10, we would need to know our 9th term. So do we know our 9th term? To use a recursive formula. And we don't know the ninth term. We only know the first, the second, and the third. So that means we're going to use our explicit formula. Our term a sub n is equal to a sub 1 times the common ratio r to the n minus 1 power. So we're going to use that explicit formula. A sub n is equal to the first term times the common ratio to the n minus 1 power. All right, so we need to know our first term, we need to know n, and we need to know our common ratio. And I'm actually going to erase that and move it down here. A sub n is equal to first term times r to the n minus 1. Okay, so let's find our common ratio. So remember, you take 12 divided by 4. You take 36 divided by 12. So 12 divided by 4 is 3. 36 divided by 12 is 3. Those are equal. So we know that r is equal to 3. Our common ratio is 3. N, we're looking for our 10th term. So n is 10. A sub 1, our very first term in our sequence, is 4. So let's plug that information in. So a sub 10, our 10th term, is equal to our first term, 4, times our common ratio of 3 to the n minus 1 power, so 10 minus 1 power. Let's keep simplifying. So we always do our exponents first. 4 times 3 to the 10 minus 1 would be 9. Then we need 3 to the 9th power. So 3 second. Where's my exponent button? Just kidding. Why don't I know where my exponent button is on this? Oh, wait. I see it. There we go. Just kidding. I want 3 to the, there it is, 9th power. I had to use that caret button. So we're going to take 4 times 19,683. That is a huge number, which is equal to 4 times 19,683, 78,732 would be our 10th term in this sequence. Fun times. All right, so now I want you to find the 10th term in the next geometric sequence. So you have 1, -3, 9, and so on. Now, just so you know, your common ratio r will be a negative number, so watch out for that as you calculate this. But you got this, give this a shot. Make sure you identify a sub 1, n, and r, and then plug it in to your explicit formula. If you need help, of course, just let me know. All right, so you should have found that your common ratio is -3. You're multiplying each term by -3 to get to the next one in the sequence. A sub 1 is 1, r is -3, n is 10. We're going to plug this into our explicit formula. We're going to have 1 times -3, and we want to make sure that negative is in parentheses because we're taking it to an exponent, and to the n minus 1, so 10 minus 1. So this would be equal to 1 times -3 to the 9th power. We're going to take -3, and I'm going to use that caret button to the 9th power. Oh, just kidding. So whenever you are taking a negative number to an exponent, you want to make sure you put that in parentheses and then take the negative and the number, so that whole negative, -3, to the 9th power. And we get -19,683. And of course, we still have to multiply that by 1. Anything times 1 is just itself, though. So our 10th term in this sequence is negative 19,683. All right. So now you need to go do your extra practice. When you're done with your extra practice, make sure you let me know so we can go over it together. And I'll see you back in class. Have a good day.